Hello everyone, Matthew here from the MattEXZY YouTube channel, and I thought I would just do a short extended, well, I can't really say short and extended in the same sentence, can I? A longer version of the QRP Pixie video I made a few weeks back, and this thing has kind of snowballed into a bit of an obsession. I put the circuit in a almond nut tin, and it looks a bit craggly at the moment. I'll show you what you can see in frame. Look, I've just got a little telescopic antenna for the antenna, and this green wire here runs to the counterpoise, which is RF ground. That's different to ground for electrical appliances. The RF ground is different. The wave kind of reflects back. And I know the connections look grossly inadequate. Look, I mean, look, this black wire isn't even coax. I get that. I'm just, fooling around because I don't want to transmit too far at the moment. So that's what we're doing. I don't have it open, but I do have another QRP Pixie circuit that I put together. And you might notice, for people in the know, that there is a transistor missing because I blew it up. I connected power and I was keying a little bit for a while, and the transistor just smoked. I think that was because either A, I was running it at too high voltage off a lead acid battery, or B, I didn't have an antenna plugged in and it kind of just fried itself. But this gives you a good representation of what the circuit actually looks like, and just fits in there like that. So moving on, just for kicks, I put in I wired a little voltmeter in parallel with the power supply. Now these things take 12 volts, and I've wired in, well, how many batteries is that? 8 AA's. They're just alkaline at the moment, and they provide a nice stable enough voltage. I did demonstrate the last video using a 9 volt battery, but 9 volt batteries are a little bit dismal, I discovered. These circuits actually pull around 200 milliamps, and that's basically the capacity of a 9 volt battery. And if you want to get any kind of real performance, I'd suggest at least this kind of battery pack. I mean, it's not fancy, but it's a step above a 9 volt battery. And second of all, I went looking around for Morse Code keys, and I soon discovered that they're quite expensive. They run about at least 8,100 Australian dollars, and because I'm just practicing at the moment and I'm kind of cheap, I kind of made up my own Morse Code key. Now don't laugh, guys. I'm sure there's a lot of real amateurs out there that know what they're doing, like way more than I am. But I'm one to improvise, and I made up a basic Morse Code key out of a small block of wood, duct tape, because I like duct tape very much, a paper clip, and some copper thumbtacks. And just for the sake of demonstration, I'll actually show you how that actually works, and I find it works quite well. So we put the radio on. Now that squeal is because the radio is very close, and it's always kind of got like a carrier signal. Well, not a carrier signal, but it's there's stray radio waves coming out. But just to demonstrate how this works, and I've discovered that I kind of prefer my thumb, and I've been keying with this for a few weeks, and I think it's quite good just to practice. I'm not looking to make any contacts or anything like that. This is all still, very much in theory, but and you might also notice that as I'm keying, that voltage, you get a good idea of how much power you're pulling. Once it goes past down 11 volts, I find that it really, the beeping, the keying effect, it just loses itself a little bit. It works with 9 volts, but it's a far more stable little circuit up here on 12. What else can I mention? I'll turn that radio off. And I'm also looking at different ways to power it. So here we have two 6 volt little mini solar panels. these are the types you would find on, say, a USB phone charger or something like that. They're wired in parallel at the moment, but I discovered that they only generate about 80 or 90 milliwatts, so I need another 2 of these like that to make it solar powered. I don't know why, but I thought it was just something maybe inspire someone to do, if they're like a prepper or something and they want to be out in the field and send some Morse code. It only sends 1 watt, or maybe 1.2 watts if you're lucky. I know in the previous video I mentioned 300 milliwatts, but that's with about 9 volts and below. As the voltage goes up, you get more power, but as I found, if you go above, say around 12.5, 13 volts, you will fry your transistor. What a shame. Oh well, they're a dime a dozen. I'll fix that. So, thanks for watching this rambling video. I hope you got something out of it. And yeah, stay tuned.